The Pathways to Knowledge model of information processing identifies 6 stages that students go through when learning to process information. They are appreciation, pre-search, search, interpretation, communication, and evaluation. More information on this can be found in the Technology as Facilitator of Quality Education model. Students in an elementary mathematics class are participating in a hands-on graphing activity. The students will count the number of M&Ms of each color they find in packets of M&Ms. Then they will enter their data into a spreadsheet and create a graph that displays their information. The students demonstrate the pre-search stage of information processing during a review session.
And you remember that we've done some graphing before, and we have different kinds of graphs, and the different kinds of graphs are used for different things. A graph is some kind of information that we use, and then we try to organize it so that we can understand how we're going to use that information. It usually represents things or shows relationships between things, and that's what a graph is.
The students are relating information to prior knowledge as they discuss the different types of graphs they have learned about. They also start building background information as they talk about the different features of bar graphs, line graphs, and pictograms. This will help the students organize their data later in the lesson.
One of these, because that might be that kind of day. What do we call those? It starts with a P. You had one the other day that I think had bunnies or something on it. Okay, yes, Josh.
Pie graph?
Oh, not a pie graph. A pie graph is something that looks like a pie. That was a smiley face, and that was an unhappy face. And we had a bunch of those. So it starts with a P, the second letter is I. Do you remember?
Picture graph?
A picture graph. That's what you called it when you were younger, yes. A picture graph. And the real name of that is pictogram.
The students demonstrate the interpretation stage of information processing as they discuss previous graphing projects. They begin reflecting on the results of their class surveys and drawing conclusions based on the data. They discuss the validity of various generalizations that can be made based on the information they collected. The teacher encourages the students to think critically about making generalizations when they interpret data.
Could we say that that was typical of all third grade classes, do you think? Raise your hand if you think so. Okay. Then which group had the most people in it? Luke.
The buckle shoes?
The buckle shoes had the most people? You think so? I'm not sure. Reuben?
The gym shoes?
The gym shoes. Okay. So do you think that most third graders would wear gym shoes to school instead of the strapped shoes and the boots and the short boots most of the time? So you could make an inference about third graders. How could you prove that? Is there any way that you could prove that most third graders, not just third graders at Riverside Elementary School, but most third graders would wear tennis shoes rather than buckle shoes or boots or anything like that? Could you prove it? Yes.
Because I can run faster in my shoes. That's why.
Okay, you can't. But how could you prove that about all third graders, say, in Grand Rapids? Could you do that? Is there any method that you could create where you could find out if the third graders at Aberdeen, more of them wore tennis shoes than the others? Could we do that? Yes.
You can have a guess.
We could have a guess, okay? And then we could have somebody who could possibly go over there and find that information out for us. Most African Americans would have been in the same line that I would have been in, which means that we have what color? Eyes. Brown. So would that be valid if you went to a different part of the city? Would you say that everyone had blue eyes? No. Okay, so you have to think about that. Depending upon different races and different ethnicities, that would not be valid. And if there's a whole class of third graders who are African American, most of them are not going to have blue eyes. Okay? So we can't make generalizations with some of the information that we have. We have to think about it and take other things into consideration. There are other factors that we have that would make our premise, and that's what we made, a guess, that would make it really wrong. Okay?
The students demonstrate the search stage of information processing as they begin collecting information. The teacher helps the students work on planning a search strategy by giving them a worksheet they can use to help them organize their data. The students first have to predict how many candies of each color they will find in a packet of M&Ms. Then they count the M&Ms of each color, recording information through note-taking.
Yes?
I don't have any.
But you're still going to put it on your graph. Okay? You don't have it. You put the word blue, but when it graphs out, it'll be nothing at the bottom. Time-wise, we're looking good. Let's get those numbers in.
The students then guess how many M&Ms of each color a partner has. The partners then combine their data on their worksheets.
Now, I had 8, 3, 11,
After the students have combined their data with a partner's, they start determining themes and patterns in their information. The students are reflecting on their results, drawing conclusions about the color distribution of M&Ms. They will synthesize their thoughts and write one sentence explaining their conclusions. This demonstrates the interpretation stage of information processing.
Okay, so let's see. We'll just use yours because hers is exactly the same, right? So look at the number of red that were there. There were 23. Now, do you think, and look at the number of blue that were there. Very few. Number of green, not as many. Number of orange. Do you think that in most packs they will have more red and brown like yours, or would they have more blue and orange, or what? What do you think?
red and brown.
Okay, then maybe that might be your sentence, that most of the time you'll find more.
Oh, okay.
Oh, okay. Do you agree with that, Stephanie?
Yes.
Yes? Are you sure? You don't want to write anything different?
I'm sure I want to agree with my pal.
Okay.
The students demonstrate the communication stage of information processing as they present their conclusions to their classmates. The students have opportunities for expressing ideas through speaking and writing.
There will be more brown M&Ms because it is more likely to look like chocolate.
Okay. Whoa, is that what you said too?
Yes.
Well, that's okay. See how far away you are and you think alike. And that's very good because, yes, maybe they look more like chocolate and people like chocolate.
The students and the teacher discuss some of the conclusions the students make, editing and revising their ideas together.
I think all cats is the same in the whole world.
Okay, so he and his partner think that all of the packs of M&M are the same in the whole world. Same in what way? And that they will have different numbers, is that what you're saying?
I don't think some packs are the same.
Okay. You're saying that no matter which pack you pick up, whether you are in Afghanistan or if you're in Los Angeles, that you could not have the same number as another pack somewhere else. You're saying it's all going to change all over the world, right? Okay, good. Anyone else have any ideas or would like to share?
In pairs, students work on organizing their information for presentation in the computer lab. Each pair creates a spreadsheet and chooses the type of graph that will best represent their data. The students are selecting an appropriate format for their information, and they will have the opportunity to reflect on their choice before presenting the spreadsheet and graph to their classmates. This demonstrates the communication stage of information processing.
Right there, look up there. I know, now I gotta write actual. A, C. 8 out of 10.